here today along with Everett.
Hi.
Today we're going to learn about gravity. So remember, our EQ is what is motion, and today we're going to learn all about gravity in this quick video, hopefully done in several minutes here. You want to try to keep it quick?
Yeah.
Okay, here we go. So today's question is, what is gravity? Maybe. There we go. Your textbook says gravity is the force that pulls objects toward each other. So remember, it's a force. Ev, do you remember what a force is?
Yes. It's like a push or a pull on an object.
Good.
Like friction.
Good. Okay, so gravity is one of these fundamental forces, one of the basic forces in the universe.
Yes.
Okay? Maybe. There we go. Here's our buddy Newton again. Ev, you want to read this law of universal gravitation?
Yes. The force of gravity acts between all objects in the universe.
Very good. So Newton came up with this law of universal gravitation that says gravity operates on an apple, on the moon, on the earth, on whatever.
Everything.
Everything. Easy enough? So, once again, gravity defined as the force that pulls objects toward each other. And Newton says the force of gravity acts between all objects in the universe. All right, you ready to get 7 big ideas about gravity?
Yes.
7 big ideas.
7.
Here we go. Number 1.
All objects in the universe are attracted to each other.
Okay, all objects in the universe.
All of them.
Really?
Every single one.
Every single object.
Every single one.
Okay. A coffee cup and a pencil?
Yes.
Then why don't they move toward each other?
Because gravity's pulling them down toward the earth.
Oh, the earth. So we're all stuck on the earth here.
Yeah.
So the force of Earth's gravity is much stronger than the gravity between a pencil and a coffee cup.
Yes.
All right. Why don't we fly off and go to the moon then?
Okay.
I mean, why don't we do that?
I mean, we could. Like, we could just get a spaceship.
Oh, okay. Get out of Earth's gravity.
Yes.
And
But we can't go straight to the moon right now because gravity is pulling us toward the earth.
Gotcha. So we're going to get to this point where we get out of Earth's gravitational pull and then get into the moon's gravitational pull eventually, if we get far enough. Yeah, okay. Let's go big idea number 2. Maybe. There we go.
Gravity can be understood with a simple mathematical equation. I mean, I just randomly put in
simple. Okay, it's
there.
pretty simple, huh?
It looks simple, but it looks hard.
Yeah, it's kind of hard. Let's look at it. F equals G times M1 times M2 divided by R to the second, or R squared. What do you think those letters mean? What do you think F is?
Force.
Force. What do you think G is?
Gravity.
Gravity. Good. It's the gravitational force.
Yes.
What do you think M is?
Mass.
Mass. Very good. And what do you think R is?
Radius.
What's a radius? Do you remember?
It's like the distance between the center of an object and the outside of the object.
Very good. Nice. So something to do with circles or spheres or something like that? Okay, good.
Yeah, stuff like that.
So we'll come back to that one when we talk about this again. Big idea number 3.
Mass and distance affect the force of gravity.
This doesn't look simple.
No, that
What
does
is
not.
this thing I made, huh? We have big blue circle, has a mass, we're just making this up, of 20,000 kilograms. Little gray circle has a mass of 200 kilograms. And then tinier gray circle has a mass of 100 kilograms. So the blue one has the largest mass. So does the blue one have the most gravity, do you think?
Yes.
Good. The blue one and the middle gray one, right, are only 1 kilometer apart. But the 2 gray ones are 10 kilometers apart. So which one do you think, or distance also affects gravity, right?
Yeah.
So if you're closer to something, there's a smaller radius. If you're farther from something, there's a larger radius. So gravity has something to do with mass and distance. Okay?
Yep.
Let's go to big idea number 4.
Yeah.
Big idea number 4.
More massive objects pull less massive objects toward them.
Okay, so the blue circle has more mass. We said 20,000 kilograms just to make
Yeah.
a number up.
Uh-huh.
And the other ones have less mass, maybe 200 kilograms, 100 kilograms. So the larger massive object is going to pull a smaller massive object toward it.
Yeah.
Okay, so is the Earth a lot more massive than us?
Yes.
So that's why we're pulled toward the Earth.
Uh-huh.
Right?
Yeah.
Okay.
That's fair.
That's fair. Big idea number 5.
Greater distance between objects equals less gravity. Less distance between objects equals more gravity.
Oh, that sounds a little confusing.
That is.
Okay, let's look at the first one. Greater distance between object equals less gravity. So over here, you have these two objects of the same mass, let's say,
Yeah.
right? But they're farther away from each other. So the force of attraction between them, these arrows, is less.
Mhm.
Remember magnitude we talked about?
Yeah.
Force has magnitude and direction.
Mhm.
These two over here are the same mass, except they're closer. So less distance between object equals more gravity. So these objects here have more gravity, experience more gravity because they're closer to each other.
Yeah.
Does that make sense?
Mhm.
All right. Big idea number 6.
Your weight on Earth is due to the pull of Earth's gravity on your mass.
All right. So here we are. Let's say we weigh 100 pounds on Earth.
Uh-huh.
All right. So that force, the Earth's gravity is pulling us toward the Earth. So when you step on a scale, actually you're just stepping between or putting the scale between you and the Earth. And then you're reading how much the Earth is pulling down on you.
Yeah.
So if it says 100 pounds on the scale, right?
Yeah.
If you went to the moon and you stepped on the moon and you put a scale, you stood on a scale,
Uh-huh.
right? And you put the scale between you and the moon,
Mhm.
the scale would read 17 pounds.
Wow.
Did you lose 83 pounds?
Quick math. I guess.
I guess so. But did you stay the same as a mass? Yeah.
Yeah.
So mass, remember, is the amount of matter in an object. You didn't change the amount of matter in you. The only thing that changed was the thing you were stepping on.
Uh-huh.
So if you're stepping on something more massive, like the Earth, your weight is going to be greater than if you step on something less massive, like the moon.
Uh-huh.
Do you think if you stepped on something even more massive, a planet that was more massive than Earth,
Like Jupiter?
like Jupiter, would you weigh more?
Yes.
Exactly.
Way more.
Weigh a lot more, right?
Mhm.
Okay. So big idea number 6 has to do with your weight. When we talk about weight, it's actually gravity pulling on your mass. Big idea number 7. Last one. Oh, okay. Maybe. We'll get there. Here we go. Albert. Albert comes and
Albert.
messes it all up here, doesn't he?
Come on.
Let's see what Albert says. Big
More-
idea number 7. Sorry.
More massive objects bend space-time more than less massive objects.
Okay, so Einstein adds to Newton's ideas, as we talked about, and says something that's more massive actually bends space-time more. So that's the reason why something less massive is attracted to that more massive object. And we'll explore that later.
Okay.
Okay? But for now, Einstein actually says this is what makes objects attracted towards each other, is the fact that they bend space-time. All right, so there's 7 big ideas. You want to review them real quick?
Yeah.
Quickly? Okay. Number 7. Excuse me. Number 1.
All objects in the universe are attracted to each other.
Number 2.
Gravity can be understood with a mathematical equation.
And remember, we have mass in there,
Yeah.
and radius,
Radius,
and then gravity.
gravity.
Number 3.
Mass and distance affect the force of gravity.
So the closer you are, it changes gravity, right?
Yeah.
Okay. Number 4.
More massive objects pull less massive objects toward them.
Very good. Number 5.
Greater distance between objects equals less gravity. Less distance between objects equals more gravity.
Good. Number 6.
Your weight on Earth is due to the pull of Earth's gravity on your mass.
Good. And then number 7.
More massive objects bend space-time more than less massive objects.
Good. All right. So if we summarize here, let's just look at the Earth and the Moon. The reason why the moon is attracted to us is because we bend space-time more, according to Einstein's idea.
Yeah.
And if you go way out into the universe, the sun bends space-time like this, let's say. A neutron star could bend space-time even more. And then this black hole, which we'll learn about in a mini question later, bends space-time even more than those objects.
Mhm.
So we'll learn more about that as we go through it.
Yeah.
So in the end, what causes gravity?
I don't know.
We don't know.
No.
It's still a mystery. So we know there's gravity, but we still don't know what causes it.
Like sleep.
That's right.
Sleep is a mystery.
That's right. Sleep's a mystery. There's a lot of mysteries in science, aren't there?
Yeah.
Gravity's one of them.
Uh-huh.
All right. So today, let's think about gravity, and I want you to answer the mini Q. What is gravity? In this short intro video. You've already watched this video right now. Number 2, watch the TED Ed video that I'm going to post on gravity. And then number 3, answer the mini Q, what is gravity, on the Google Doc. All right, is that about it, Ev? What do you think?
Yes. I think that's about it.
Okay, do we understand gravity a little bit so far?
Yeah.
All right, so how would you summarize gravity? What is gravity?
Gravity is the force
Mhm.
that keeps objects attracted to each other.
Good. And what factors affect gravity, this force?
Distance,
Distance and
mass.
mass. Good. So those are the big ideas with gravity. And we'll see you next time.
Peace.